It's my honor to introduce Haven Pierce, an assistant professor of landscape architecture at UC Davis, and Kevin Perry, principal of urban rain designs. Take it away, team.
Okay, so now we're going to move into design tips or design considerations for rain gardens. And just to caveat this, that this is, again, just more tips and considerations. This section isn't necessarily going to show you the details of how to place individual plants or design your rain garden. That's a longer process to go through, but this is hopefully, again, kind of give you the key points of rain garden design. And one of the first things you would want to do before you get your shovel and start getting into things is just kind of analyze your yard for what are the right conditions for rain gardens there. So here's some questions maybe to ask is, where's the best spot for your rain garden? What are your existing soil conditions? Where are the source points for runoff? Is it from the roof? Is it from driveways? What type of grading exists at your property? Is it relatively flat? Is it steep? Are there existing mature trees there that you would want to avoid? And then also looking at more the site layout applications. What are the rain garden setback requirements needed for your project? And then also asking the question, can you safely allow excessive water, stormwater to exit your property if your rain garden is overwhelmed with water? So let's focus in on locating your rain garden. And if you kind of look at a typical residential lot, kind of longer and skinny, and obviously all residential lots are different, but I'm just kind of showing a typical example. You can look at backyard locations, side yard locations, and front yard locations, and kind of breaking it down into those three components. And each of them have their own kind of pluses and minuses for locating your rain garden. If you're looking at a backyard location such as this, a lot of times you can have quite a bit of space to capture rainfall, say from your building downspouts. They're easy to access. It offers maybe a more private setting for if you wanted to not only have the rain garden, but maybe some seating or some lighting. It provides a more intimate space potentially if it's more private in your backyard. But if the grades are such that the low point is the street, oftentimes the overflow point is a little bit complicated, because what happens if you have a whopper of a storm and your rain garden fills up, you need a system to allow that water to move from the backyard to the front yard or wherever the lower point is on the property. And so you may need to have a pipe system to overflow that water to wherever that low point is. Side yard locations can be a little bit tough. Oftentimes it's more like this. Some people have larger areas for side yards, but oftentimes it's just getting from the front to the back with a pathway with not much available space. So typically they are very narrow spaces. They're usually paved. The overflow of the water needs to be dealt with. You may have to pipe that to the front or wherever the lower part of the property is. But again, if you do have a larger side yard condition, there may be some opportunities to integrate rain gardens along the side of the house, providing you have the appropriate setbacks, which we'll talk about in a little bit. Probably the easiest spot is your front yard for a couple of different reasons. Often they do have quite a bit of space, and you'll find out later that you don't necessarily need a large amount of space, but if you're trying to have a kind of a bigger impact of your yard, this is often the spot to do it. The downspouts are typically easy to grab stormwater from. And probably the biggest advantage is that any overflow that does happen is typically at that front part of the house at the street level, where water could just exit out the rain garden and go into the street. I guess one disadvantage is that it's a little bit less private space, so that if you did want to incorporate some, again, kind of special places in there, it's kind of open to the public view there. But from my perspective, the front yard is the ideal spot when you're looking at the kind of the raw conditions of being able to capture, infiltrate, and then overflow stormwater. I'm going to hand this back over to Haven to talk about soil conditions.
So this is going to be one of the first things that you want to start thinking about is what kind of soil do you have? And it can get really technical, but it doesn't need to. Essentially, we're going to be looking and see if you have one of 3 different types of soils. And so the 3 main soils are clay soils, sandy soils, and loamy soils, with the loamy soil being like the be all end all. If you've got it, like you're dancing, you're so happy. Typically what I'm seeing, I mean, I'm here in Davis in the Central Valley, and I've seen Bay Area too, it's a lot of clay. And so the way to tell clay soil is that it's going to be very sticky. So you can actually, it feels like you can mold it into clay. And so you can actually shape it. What it means is that it's really slow to let the water through. If you think about clay vessels, right, they're holding the water. So clay can hold water for a really long time, which means it doesn't infiltrate as fast as, say, sandy soil, right? So if you think about sand and you think about water going through sand, it's going to go through very, very quickly. So lots of air space, and the water goes through really quickly, but then because it doesn't hold the water and the nutrients as well as clay, it's not going to be as fertile. Then you've got your loamy, like brilliance, that takes those 2 conditions and combines them. So it's going to be a uniform mixture of the 2, really rich in nutrients, more air, a little bit of airspace, good infiltration, and then lots of good fertility. Next slide. So in order to figure out your soil texture, essentially what you're going to do is you're going to just take a handful of soil, add a little bit of water, and then you're going to form a ball with the palm of your hand. And so you want to see a little sheen on the surface. And then you just want to start pinching and sliding the soil between your thumb. I mean, I'm doing this in front of the screen like that. So there you go. And you want to form ribbons of soil. And you want to do this until the ribbon breaks away from the rest of the soil. And then you're going to measure the length of that and you're going to record it. And so the difference is with sandy soils, you're not going to get a ribbon, right? The sand is just going to break apart. With the loamy soils, it's going to be a pretty short ribbon and it'll split pretty easily and it'll break away at about ½ an inch. And then with the clay soils, that, you know, you're just going to be molding. Basically, you're creating a pot out of that clay soil. So long ribbon, about 1 inch long. Next texture, or next slide, not next texture. But then, more importantly, I think than anything else, is looking at what you've got in your soil in terms of organic matter. So really, this is where you get your hands dirty. This is where you can kind of play around and see what you've got, right? So many of the conditions, especially both Kevin and I work like in commercial applications and a lot of time on campus. A lot of the time, the soil has been really compacted. It's not so great. It's really hard to use. A lot of if you've got good soil and you can dig it up, look for those worms. See if you've got them in there. See if you've got compost in there, and if it kind of breaks apart in your hands. But if you see little pieces of white mold, or you see nematodes, all that kind of cool stuff, that's the kind of thing that you want to look for. If you've got that, you're in good shape. Okay, next slide. And then you can test your soil's infiltration rate. And again, we're getting into the scientific stuff here, and you can have someone come and do this for you. They're testing labs that'll do it, and we're making it look, very fancy, but the reality is this is something that you can do, and it's pretty easy to do, just to get a sense of how quickly will that water go through. So you're gonna dig a little pit, then you're going to place a ruler in the bottom of the hole and, make sure that it reaches the top. Then you're going to fill the hole with water. You're going to get the soil totally saturated, right? You don't want to just do this right away. So with clay soil, it might take a little while, might take overnight. So note the time, then fill the hole with water. Once it's been saturated and wet, fill the hole with water, watch it, and then when the hole is empty, note the time and figure out how long it takes to drain the hole. Then you're going to record the rate into inches per hour. And then through that, you'll be able to figure out your general percolation rate. So if we go to the next slide, what you see is that if you've got, this is another way to figure out kind of what kind of soil you have. Sandy soils, greater than 5 inches in an hour. So lots of water going through really quickly. That beautiful loam between 1 inch and 2 an hour, 1 to 2 inches an hour. And then clay soils, it takes a long time. We're talking 1/4 inch of water infiltration over an hour. So next slide.
And then, just to jump in, and then having clay soils doesn't preclude you from having a rain garden at your property. It just suggests that maybe that water is going to go into the ground more slowly, but it also maybe suggests that you may want to amend the soil, and we'll talk about that a little bit later during the construction section, and adding the organic matter to make that soil perform a little bit better, both from percolation standpoint, but just overall plant health too. So yeah, that doesn't, just because you have slow draining soil doesn't mean that you can't have a rain garden.
No, we all make it work.
Yes, we do.
Actually, before we move on, we do have a question from the audience, if that's okay.
Yeah.
So one of our audience members asked, why doesn't rain garden go into the earth when the landscape is lawn with special bought rocks? And so I guess they're kind of asking, what, if you have a turf lawn, doesn't that also allow some infiltration? And so what's the benefit of, taking out a turf lawn and using a rain garden if they both have some infiltration into the garden?
I can jump in, but do you want to go first, Haven? Because just from the switch over of the plant application, and then we can talk about the water too.
Yeah, I mean, there are a couple reasons. I mean, one of the things is that, yeah, different plant materials also have higher water absorption rates, right? If you've got plants with big leaves, they're going to absorb much more water than a fine blade of a grass. And so if you're actually sending your water towards a rain garden, then not only do you have the benefit of sort of that deeper profile and the basin to capture that water, but then you also have these plants that through evapotranspiration can actually suck up the water in there and then put it back out into the atmosphere and also let it go back into the ground. You're also, by removing the lawn, you're reducing a lot of the lawn maintenance and a lot of the, if you're fertilizing your lawn, a lot of the pollutants too that are going into the water. And then Kevin, I know you want to add to that.
Sure, yeah, you've got those points right on. I think also just having the ability to have more of a biodiverse landscape other than lawn. Lawn often will serve one purpose, and to have a kind of a monoculture landscape. But by introducing different plants and regrading the soil to allow for that capture of water, you're introducing kind of a micro ecosystem there that replicates more of the natural system that we would typically have. And so I think it allows for a lot more overall benefits than just having lawn. The other point I was going to say that, talking about maintenance, yes, you can certainly allow water to move into lawn and even have that lawn recessed. But what I've noticed over time through many years is that the constant mowing of lawn, there's a thatch buildup that occurs. And so you don't get as much infiltration because a lot of the clippings from the lawn reduce the amount or the ability for that water to get into the ground. Whereas if you're not mowing, and you just have more of a native or adaptable landscape, you are not introducing kind of that thatch layer. So hopefully that helps answer that question. Okay, so moving on to more analysis, kind of finding your runoff stormwater sources. So one of the easier sources to identify is your rooftop. So looking at ways to capture water from your downspout location is certainly one thing, but also not forgetting other impervious area surrounding your property. So it could be your driveway application or just simple walkways. How, depending on how the driveway and the walkways are draining, there's an opportunity to then utilize the existing landscape space to capture that runoff. I talked a little bit about grade or the lay of the land at your property. Steep grade conditions, not uncommon in the Bay Area, sometimes even more common than in the flat areas, but special considerations need to be taken into account when locating your rain garden in areas where you have steeper grade. Again, similar to the soil, with the clay soil application, it doesn't necessarily preclude the idea of having a rain garden, but it just means that extra thought needs to be taken as to how you're going to shape the land for that recessed landscape space, where the available space is given the way the land is already shaped, and then making sure again that from larger storm events, can that water exit the rain garden safely? So just some extra considerations. Also, looking at working with your existing trees, and I don't know how many projects I've worked with where you have mature trees there and we're going to squeeze rain gardens into different spaces, and it's certainly doable, but you just want to be mindful of the existing root zone of those trees. So you would hate to lose a tree in the process of creating your rain garden. So a general rule is to try to not excavate within the drip line of your tree, which is basically, if you're looking at your tree canopy, draw lines down from that where the canopy is extended out. That's essentially where a lot of the root zone is in the ground. So if you're cutting into your lawn, you're cutting into your landscape, you want to try to avoid those areas as much as possible from the drip line in towards the trunk of the tree. Setback requirements for rain gardens, and this is kind of coming out of the rebate program, looking at different requirements. Again, I've drawn up kind of a completely hypothetical site plan of a residential project. We've got a couple of trees, we have a patio, a walkway, you've got the house, the driveway, and lawn spaces throughout. When you're looking at the specific setback requirements for rain gardens, you have a couple of different things. Notice first and foremost that the rain garden doesn't want to be any closer than 10 feet from the building. So you can see kind of these red zones, which is kind of the available space for the rain garden. You can see it's offset from the building foundation by 10 feet. Likewise, there's a 5-foot perimeter setback from any of the property lines that you see there, as well as a 3-foot setback from public sidewalks. So when you squint your eyes and you look at this, there's actually quite a bit of space for a rain garden. If you look at those, again, those kind of red areas that I've shown in through here based on the setback requirements. But then when you start to overlay, wow, we do have some existing trees there and we don't want to harm them, those areas start to shrink up a little bit. So now you're looking at kind of what I'm showing here in the red here. But look at the opportunity that exists. If you're doing a quick site plan and you were reducing maybe the front yard, all the lawn goes away and you have a rain garden that's 10 foot offset the building foundation, 3 foot off the sidewalk. And in the backyard, maybe you've got kids and you still want to have some lawn space. You can certainly still have that landscape space, but we're creating a rain garden that adheres to the setback requirements as well. What are some shapes? What are some good shapes for rain gardens? And the simple answer is pretty much anything goes. You can have more formalized rectangular shapes, such as this, even skinnier rain gardens. As long as they meet the space requirements, they're good. Or you can get a little bit freeform. Maybe it's more of a serpentine look to it, or just kind of I don't know what you call this shape, maybe a kidney shape for a rain garden. But like I said, anything pretty much goes with it. They can be whatever they want. And I think that's advantageous when you're working around different site conditions, whether it's a setback requirement or an existing tree. Maybe it's a circular space if you like circles, or if it's a triangular space, that's certainly good too. A lot of consideration is how much space do I need for my rain garden application, and the rebate program is showing some minimum criteria for that. So when you're looking at capturing impervious area, whether it's from a roof, a driveway, a walkway, or any combination of that, you want to be able to have at least 300 square feet of available stormwater capture from those areas. That's kind of the minimum. Now, obviously, rooftops can probably be way more than that, which is great. We can capture more water. And then if you're looking at the kind of the actual rain garden size, what we'd like to see is a 4% minimum size for rain gardens. So if you've got, for example, 300 square feet of roof area, if you look at that 4% rule, we need at least 12 square feet of rain garden space. So just to put that in perspective, maybe that's a 2 by 6 foot area. So that's the minimum for a 300 square foot space. So you can really fit these rain gardens into nooks and crannies as long as they meet that kind of setback offset. So kind of looking at a brief example of sizing for something like that. I've actually got 2 examples, so I'm just kind of picking on this one. So let's say that this roof has 800 square feet, and based on the setback requirements and what we'd like to see with this particular landscape, we have 150 square feet of available landscape space that we can convert from a lawn into a rain garden. You do some basic math by dividing the rain garden space by the roof runoff. And in this case, we have almost 19% size ratio, which is great. And the point here is that the 4% is, again, the minimum. You can take out as much space as you would like to have for something like this, and that's great. But we do want to emphasize that 4% minimum size for rain gardens. Hopefully you can do much more than that, like this example. So again, this is the kind of like second example. I'm looking at that setback requirement that I was talking about, that same site plan. Let's just take this rooftop, and we're going to combine it with the patio space. That's going to equal about 1,670 square feet of available capture of roof or just impervious area. And we've, again, allocated about 420 square feet of rain garden space. So again, doing that simple math, dividing the 420 into the 1670, we're looking at 25%. So way above the 4% minimum, which is great. The other thing to consider with design application is just the overall programming of your space. And what I mean by that is that rain gardens can have just kind of a single purpose function, in that your yard, your rain garden is just designed to be able to capture that water into this landscape space and infiltrate it, and that's great. And you know, removing a portion of the lawn to do that. But there's also the opportunity to integrate the design, and this is where it gets kind of fun, I think, is to start creating spaces with your rain garden applications. So maybe there's some seating, or so yeah, like this example under here, they have their rain garden. They have this is in a front yard location where they have just kind of a seating space. And I walk by these neighbors all the time and talk to them and compliment them on their rain garden. This is in Davis. And it's becoming more and more popular to have these front yard spaces act as more seating spaces or just interesting spaces. It's another example where there's a rain garden application, and they've done a bold design statement by having you walk over these large planks of wood, so you feel like you're suspended over this landscape. And again, it's kind of when I talk about multi-purpose landscaping, it's starting to create spaces, people spaces, placemaking spaces, other than just simply managing that water. And it could be just the simple application of a bridge and allowing people to walk over it and maybe have an opportunity to sit down. Or in this case, there's a small linear rain garden right up against a raised vegetable bed. You wouldn't want to have edible plants within the actual rain garden piece, but it's showing kind of a combined use of stormwater management with edible landscaping too. Or maybe it's just creating a statement here that this particular rain garden has some poetry associated with it, which I think is kind of nice. There's some more examples of that. Another common question that's asked of me and others is, how deep should these rain gardens be? And if you remember from my initial definition, I had mentioned that these should be shallow systems, but that's pretty vague. And so I found that I had to come up with a basic formula for what looks good but also what is functional in terms of capturing the stormwater and allowing it to move into the ground. So I kind of came up with this formula that suggests for every horizontal, if you're looking at a cross section, a slice through your rain garden, for every horizontal foot, let's say you've got 6 feet of horizontal space for a rain garden, you slice through that, there would only be about 4.5 inches of grade change. So there's, for every 1 foot of horizontal spread, there's 3/4 of an inch of vertical grade change. So if you look at this kind of this table or this graphic, it's suggesting that even if you have say just a really small rain garden application, it's only 1 foot wide, maybe it's only about an inch or so deep. And then gradually, as you start to get wider and wider with your rain garden application, you can go a little bit deeper. But I would suggest not going any deeper than 6 inches of actual ponding depth for rain gardens, just because the plants themselves have a more difficult time trying to infiltrate that much water in a reasonable amount of time. You don't want them to be super deep with water. So just to put this formula in action, here's an example of a 12-foot wide rain garden. And if you kind of take that same formula that I have, it's suggesting that maybe we have 9 inches of vertical transition, but there's a outlet on this that only allows for 6 inches of water to be captured in any given storm event. Same here, where we have about 9 foot of horizontal spread. I'm suggesting maybe just 6 inches of vertical transition or 6 inches of ponded water with this application. So just something to keep in mind. Again, a lot of times designers and contractors want to make these rain gardens super deep, and you really don't need them to be that deep. And actually, from an aesthetic standpoint, you don't want them to look that way either.
You don't want a big hole in the ground.
You certainly don't. You certainly don't. And so when we're talking about grading, there's different ways to transition and grade, since these are lowered or recessed landscape areas, again, designed to capture this water. There's a couple of different approaches. You can just allow that grade change to occur by manipulating the soil downward, or you can make a more abrupt change or a vertical containment strategy. And so just kind of showing some examples of more of a vertical containment. So you're kind of making more of an abrupt change. There's different materials for that. You could just use a simple stacked wall application, some different examples of that. Or you can start getting a little bit more, I guess, fancier or unique in that grade change. This is an example of a project that I built with students at UC Davis that we used just a wood 2x12 header board that's separating the recessed portion of the rain garden with an upper terrace application. And so that's using wood, but you could also use metal. A lot of different ways to do that. Just kind of showing some examples of that. And obviously, when you're looking at these types of applications, we're looking at a more enhanced design and a little bit more costly application. But for if you want that type of a look, there's a lot of different materials to do that. Also, if you're looking at slopes and the slowing and the containment of water, there's a couple of different ways to do this. You can terrace the landscape by keeping the slope still the same. So that upper graphic there is suggesting a slope there. And instead of having that water move really fast down that slope, you're breaking it up with what we call check dams, or just the ability to slow that water down and capture it and force it to infiltrate before it can slip down to the next check dam. So you can do that by maintaining the slope and then just adding rock or other measures to slow that water down, or you can literally terrace the grade down and kind of flat slopes to allow the water to move from cell to cell. And again, the latter example again would be a little bit more of a costlier approach, but there's different ways to deal with those steeper slopes on your property. So one of the most fun applications, I think, especially with dealing with water, is transitioning that water from, say, a building downspout to the rain garden. And remember, if we're looking at kind of a 10-foot offset from the building foundation to the rain garden, we need some methodology to get that water from point A to point B. So there's a lot of different ways to do that. Here's an example, again, a built example from my students where we built a wooden runnel, kind of aqueduct style. You can see in the background there, the downspout, and we're conveying that water about 14 feet away from the building and letting it slip into the rain garden proper. But there's a lot of different techniques. Here's an example in San Mateo, where it's actually an apartment complex where there's the downspout, and they built a kind of a U-shaped metal channel to allow the water to move into a small rain garden. I see that more and more common. This is actually at a school in San Mateo County, or even above ground conveyance systems, again, and kind of aqueduct style. And this is a project that Haven built with her students, is at UC Davis campus, where, as you can see, the downspout was redirected into a metal channel, allowing that water to move over a walkway and into, well, it's an elaborate system, but it's fun to watch. It goes into another channel and eventually into a rain garden space. This is one of my quick and dirty applications where I had taken a PVC pipe, just a simple PVC pipe, and cut it lengthwise to allow water to move from a building downspout into a linear channel. Or you can have this, again, be of different materials. In this case, it's metal. Again, just kind of moving water from point A to point B. There's an application up in Portland for utilizing stone. The water trickles through these gaps in granite. Or maybe even building a concrete channel to allow that water to move away from the building. So a lot of different ways for surface conveyance applications. And then the simplest is just allowing that water to move on the surface before it gets into your rain garden. So maybe it's just a simple rock channel that does that. A lot of times you may want to introduce subsurface conveyance, and I could see this happening if you wanted to, for this example in this cross section, maybe you've got the building downspout, but then you also have a lawn area that you want to maintain, and then farther away you have your rain garden, or maybe it's not lawn, and maybe it's a paved area and you want to move that water underground. You could still do that by using solid drain pipe or even trench drain systems to allow water to move from the building to the rain garden. And the other fun part is allowing water to move underneath or through walkways. And there's some really nice, just simple but yet elegant examples of doing that, allowing these small footbridges to allow water to move through. In this case, the stormwater swale or rain garden is fairly close to this building application still, but almost 10 feet away. But the water is moving right through their entrance stoop there, which I think is quite nice. Okay, Haven, I'm starting to lose my voice, so take it over.
It's good because we're up to my favorite part. So Kevin was talking about some of his favorite parts of the design elements. Well, for me, it's the plants. And I just get super excited about all of the different possibilities and how we can really start thinking about plants for rain gardens and what plants are going to work and what plants are ideally suited for this. Next slide. So really, when you think about the plants that are appropriate for rain gardens, the main ones, it can be tough, right? Because we see so many beautiful examples, I feel like, from the East Coast, where we've got, and from Europe, and so totally different palette of plants. And they're doing these wonderful things, and they've got different conditions, right? For us, the trick is that we have these really hot, dry summers, and that we don't get that rain throughout the year. And so for the East Coast, the Europeans, because they've got regular rain, the palette of plants that they can use is much more expanded. So for us, it's really a challenge of figuring out what are these plants that are drought tolerant, but also can survive in an inundation of water. And so this is kind of, both Kevin and I have been working on this together. Like, what is our California plant palette and how can we integrate that so that we can create our own West Coast version of these fantastic rain gardens? Next slide. So thinking about the sunny conditions, right? I mean, thinking about the fact that, I mean, my sister lives in Amsterdam, right? You look at the weather there, it is raining every single day. They had maybe a month of sun and now it's gray and rainy. And so they can do these wildflowers. They don't need to worry about irrigation. We have sun, we have hot weather. And so we need to think about how are these plants going to respond? And frankly, one of the things that I think is really important to think about with rain gardens is when we're talking about that inundation layer and the plants that can really take the wet, we're really just talking about that bottom layer of plants. Anything kind of up on the sides and the edges, there we want to think drought tolerant, right? We want to think about plants that we're going to put in our garden regularly. Maybe they take a little bit more water, but it's really just that bottom layer that's going to be the one that's sort of tricky for us. Next slide. And then thinking about, okay, well, sometimes we do have these shade areas. And if we're trying to reduce our irrigation, then it's what are the plants that can deal with hot, dry shade, which is another. I mean, I get so excited about plant lists. And so we can talk in the questions section. I'm happy to share some of the lists that I've been able to find of plants that do well in hot, dry shade, or plants in full sun. Plants that, you know, those plants for that bottom layer, like that's for me the really fun part. But so designing a rain garden isn't going to be much different from designing any kind of garden, where you really have to think about what are the surrounding conditions and then what are the plants that will respond to those conditions. Next slide.
I'll talk to this one, Haven. So this is again an example in Davis looking at, looking at that interface, since many of you may be just taking out a portion of your lawn, designing for maintenance between that interface between a lawn application and a rain garden or an ornamental garden. A lot of times it's difficult to maintain that edge between the two types of landscape systems. So what I found very useful, not just in residential application, but in commercial applications as well, is to have a strong demarcation of what that is, usually in the form of what we call a concrete mow band that allows for easy maintenance. So if a mower wants to obviously mow the grass, it's easier to do that. If you have just lawn and then landscape, oftentimes it's difficult to maintain that interface really well.
Yeah, metal edging is also one that I use a lot, or even wooden edging. I mean, if you have a linear edge, you can put in a 2x4 and use that as edging, and that also does that demarcation. So this is another one. This is an example of a rain garden at the UC Davis Arboretum. And so I put this in as an example of designing for low maintenance because you can see that there really aren't a lot of species in here. It's all grasses and it's just a few different varieties of grasses. And so because you don't have a garden and a full like flowers at all different seasons, you don't have to worry about all of the maintenance that involves with that of deadheading and making sure that they're doing well. And the grasses are allowed to grow into each other. And so then the weeding becomes much less because it's all starting to become, so you've got kind of these monocultures within that large area. And so one of the ways to design for low maintenance is really to create spaces where you don't let the weeds come up through ground covers, through grasses, and letting the plants really take over so that the weeds can't get in. Next slide. And then thinking about plant density. And really, I mean, one of the things, if you look like, say, the poppies, one of my favorite tricks for designing rain gardens is relying on some native wildflower seeds for that first year, using annuals to really fill in the space. Because if you've seen a newly planted landscape, you really have, if you're doing it correctly because you want to give some space to allow these plants to grow up and grow into each other, you've got lots of spaces in there. And so if you use some of these wildflowers, and like poppies are the best example, right? Because they fill out the whole area When they're done, you can just yank them out, but it creates that space, and it gives you that instant garden that I know as a gardener, I'm impatient for, right? It's one of the hardest parts for me is waiting for everything to fill in and see what everything looks like. So you want to really think about following those rules. So figuring out what is the full width of that plant when it's grown, and then spacing accordingly. So if something's going to be 3 feet wide, then placing those 3 feet on center so that they'll grow into each other so that they just touch, but they're not crowding each other out. And if you're impatient, trust those annuals, because they're really a great way to make it look like it's full pretty quickly. Next slide. And then this is where it gets into this idea of what are the plants that we use. And so I am definitely a huge proponent of California native plants. They just are so good for the biodiversity. They're so good for the beneficial insects. They're amazing to bring into sort of the urban landscape. And so many of them, I mean, we're in California. And so like, it's different using California natives than other natives, because we've got such a huge variety, and they're really beautiful and they can do well in a garden situation. So that's sort of the first place that I go when I'm thinking about what are some plants, because these are plants that a lot of them, these are the conditions that they live in, right? They're already adapted to the hot, dry summers and then these wet winters. So the ones that are on the edge of a wetland or maybe near a stream, they're the ones that I'm going to go to first. But at the same time, I'm a designer. And so I'm not going to just force this native thing saying, oh, it's got to be native and, you know, be super dogmatic about it. I want it to be beautiful. I want color. I want people to walk by my rain garden and say, oh my goodness, that is absolutely gorgeous. So I am of the, let's take a little bit of each. Let's see what plants do well, and let's try and adapt these ornamentals, these tried and true that we know, mix them with some natives and see what we get. And so just really briefly, next slide. One of the things that Kevin and I are doing is we're running all of these different trials to see how the plants do. And so we have one example that Kevin designed where he's using a lot of plants. It's a mixture of native and non-native, but they're plants that are commercially available, that are really pretty easy to find. And we've edged them along a rain garden at the top, the bottom, and along the edges. And basically we're letting them see, we're seeing how they do. And most importantly, how do the ones at the bottom do? If they're really inundated with water, how are they doing? And so then now we're extending that trial, and we're going to start looking, I'm starting to look to plant in the fall. These are going to be all California natives. So just focusing on natives, but these are ones that you can get in the nursery trade that you can find pretty easily. So like, you know, all 3 of these, for example. So this is like on the right is a Penstemon Margarita Bop. In the middle is your California fuchsia, and on the left is a monkey flower. So most of these you can find in a nursery. And then we're going to try what are the California natives that are like maybe really native to our watershed. Like what are the local ecotypes that thrived here before that may not be so easy, but that we can grow from seed, that we can try and find and see how they do. And then maybe if they do really well, start thinking about how can we introduce those into the trade. Next slide. So in terms of designing for biodiversity, really, I just want to give you some tips. Again, this is just like some things to think about so that when you come out of here, you're excited and you're like, okay, what do I need to do? So one of the cool things is this idea of creating niches, right? Designing landscapes in layers so that you go from sort of a lower layer to an upper layer, and then, you know, medium layer and higher layer, because that's where that creates places for birds and insects to hide, to nest, to forage. And so you want to have vertical layers of different heights of plants, right? So the ground cover, small shrubs. And then the thing that I think is really cool that's like really important for rain gardens is this idea of edges. And edges tend to be like ecologically, this is where all of the wildlife congregates. This is where like when you have the different types of vegetation, for example, the wet edge versus the dry, that's where they flock. Your insects, your wildlife, your birds, they love those transitional zones. And so by creating a garden, a rain garden, we're actually putting that in there, and we're creating those zones, especially in urban, suburban areas where we may not have them naturally. Next slide. And then thinking about plants. And so, you know, general plants, I mean, I think above all else, my big one is experiment, right? Just try it out, because you don't have to fill your entire rain garden with the same one plant. Test, you know, I had a friend who would put in rain gardens for people that he designed and installed them. And in every rain garden, he would ask them and say, this is kind of a corner that you may not see something. Can I test this plant here? And so he had these test plants across rain gardens all over the place. If the plant didn't do well, he'd replace it for no charge. But it was just this kind of ongoing research thing. So think about like what might work and then try it out, because you've got nothing to lose. Additionally, you want to use plants that bloom at various times of the year, so that you've got constant flowering, not just for the aesthetics, but also for insects, birds that want to use that. I already talked about the mix of California and ornamental but adaptable plants, so the drought tolerant. And then think about this idea of resiliency and climate change. And I mean, you know, if you're all in the Bay Area, your temperatures might be getting closer to the Davis ones. So like, what are some of the, like, maybe you want to look at Central Valley native plants, but then also thinking about what are some of those Australian plants or New Zealand plants, and maybe they'll do really well. So playing around with those too. Next slide. And then thinking about the birds specifically. So I'm just going to briefly go through some of these, you know, thinking specifically about biodiversity and wildlife. Adding stones and logs for the birds to perch on, that really helps them search for food. Plants that actually provide food during the different seasons, so seeds and berries. Using your own soil, yes, I mean, amend it, add the compost, that's cool, make it great, but you don't need to use like potting soil. Right? The native soil is what's going to encourage that healthy invertebrate population and bring the birds in to get the worms and you know, and do really well. And then this idea of same species clumps, which is another one that works well both aesthetically and for the plants and for the birds. Because when it's in clumps, it's going to attract the birds, it's going to attract the insects to that same species. And aesthetically, it looks good to our eyes too. Our eyes aren't just like one of everything going all over the place, like my hands, maybe you guys, sorry. But what it does is it focuses and aesthetically it calms our eyes and it just makes for a better design. And then a little bit of leaf litter. We don't want leaf litter all over the place, but a little bit is good for the birds. Next slide. And so then thinking about the bees too, right? I mean, we've already got colony collapse happening with our honeybees, but California has, I think it's 1,600 species of native bees. So if we want to promote native bees and we want them to kind of step in if our European honeybees aren't doing so well, because the native bees are also great pollinators, what are some of the things that we can do? Well, some of the bees are ground nesting bees. So it's okay if you leave like a little sand or a little area that doesn't have mulch in it to let them nest in. And with the water of a rain garden, that's like perfect conditions. Again, here I am with the wildflowers. Wildflowers are fantastic for bees. Native wildflowers, even better. So use a mix of perennial and annual seeds, primarily native plants for the bees. Color-wise, blues, purples, violets, yellow, those are the colors that are going to bring them to you. And then the same thing of the clumps. Here, it's depending on the size you have, but to really get the bees to hone in on your plants, 4 foot or more clumps is ideal. Next slide. And then, I mean, obviously we want our butterflies, right? And so in terms of designing for butterflies, what we want to think about, you know, so rain gardens, if you plant the plants that the caterpillars want, that's how you're going to get the butterflies. So thinking about Asclepias milkweed for your monarch butterflies, or pipevine for the pipevine swallowtail. So the primary food plants for the caterpillars, but also plants that provide nectar for the butterflies when they're grown up. And then you can add that, you know, not only are you bringing in the biodiversity, but aesthetics, you've got butterflies in your garden. Next slide. And then we can't overlook the beneficial insects, right? I mean, yes, the ladybugs are cute, but there are also some amazing ones that like stick bugs and I never remember all their names. And this is exactly, I'm perpetuating this whole thing that all we know about for beneficials are ladybugs. But there are some amazing bugs. Like if you think about sticky plants like columbine, this is a plant that it actually produces a resin that the little bugs go in and they get attracted to, and then they get stuck. And then the predatory bugs, they come and they eat the little bugs. So the plant's protected. The big bugs, these predatory bugs, they get to eat and everyone's happy, right? And then it's also amazing stories to tell people. This is the other thing. Like you could tell people awesome stories about the plant and insect interactions that are happening in your very own garden. Great cocktail party talk, I'm just telling you. So things to think about is the same sort of things like rocks and logs. And then Kevin, I will turn it over to you for mulch.
That sounds good. So there's quite a few different types of mulch materials that are common within rain garden applications. You've got arbor mulch or organic compost a lot of times, even inorganic mulch such as pea gravel and river rock. And there's applications for doing that. So if you have conditions where you say on the side slopes or the upper areas that's not directly, you have your rain garden, but the water isn't necessarily touching that mulch or that plant material, go for organic mulch for sure. Allow it to be more woody material. What I found in the past is that when you have water and mulch mixing together, a lot of times that organic mulch can float to the surface. Not always, but a lot of cases that happens. So I've put down a layer of pea gravel, or it's very common to utilize just river rock in the areas, again, that's more wetted, where you have a lot of either energy or flow of water, so that you're not carrying mulch material or eroding it away. So you've got organic mulch, pea gravel, river rock, and the placement of it kind of depends on where the wet areas are within your rain garden. I'm also going to talk about just general overflow. I've talked multiple times on safely conveying the larger storm events when you do have rainfall. So this is an example of a retrofit, removing a portion of the lawn at a schoolyard actually, and the retrofit of the downspout to go into this rain garden. It fills up with water, and then it simply just overflows downhill and allows that water to move back towards the street like I was talking about. There's also the option of just having piped overflow systems, and these don't have to be large pipes, but just enough to allow that water to move into a pipe system where it can be taken to a lower portion of the property or out to the street zone. So just kind of looking at some of the checklist items, if you're looking at design and planning of your rain garden, it's kind of wrapping up the design portion of this section. Some questions here for you to ask is the rain garden, obviously, is it 10 feet away from the building foundation? Are you representing the setbacks correctly? Is it 5 feet from property lines, 3 feet from sidewalk zones? Are you meeting that minimum 4% sizing criteria? Are you capturing at least 300 square feet of rooftop and or hardscape area? Is your rain garden located down slope from a building downspout, so you have positive drainage to make sure no water's backing up against any sort of structure? And then what we didn't talk about too much today, but it's important, is your rain garden avoiding any utilities? And it's important when we talk about the construction section to look at where those utilities might be. And then, as we talked about before, what kind of soils do you have at your space, and do you need to amend them for your rain garden? And I know this is a lot to take in, and but you can do this. You can do this on your own. Believe me, you can. I've watched people do it, but if you ever need some extra help, you've got a lot of different resources to do that. You can utilize landscape architects, landscape designers who specifically work with residential landscapes and rain garden applications. You could look into your landscape contractor industry that have a lot of people that are very knowledgeable with this, as well as just going to your local plant nursery and talking about your project and asking them questions. We already mentioned that we've got the master gardeners that are here to help as well. If you have issues with, if you have concerns about your property in terms of the grade of the property, or worried about water next to your house, you could utilize civil or geotechnical engineers as your project if it's more complex than you think it's something that you can handle. As well as if you're looking at the soil conditions, you can certainly look to soil scientists to lend a helping hand as well.